Hello there. In the last video we talked about what we called a relation between two sets. Let us briefly overview what we talked about there. So let us consider set A together with a set B and a relationship between them called R. So let us assume we have the numbers 2, 3, and 4, and in B we have the numbers 1 and 2. Suppose A is related to B in such a way that 2 is related to 1, 3 is related to 1, and 4 is related to 2. Then this connection between these two sets is called a relation between A and B. And we can rewrite this in a graphical notation by looking at all x values in A and all y values in B by putting the x values on the horizontal axis and the y values on the vertical axis. If that is the case, then we have 1, 2, 3, and 4 on the horizontal, 1 and 2 on the vertical, and then we can plot these points. So we have 2, 1, 3, 1. So 2, 1, 3, 1, and 4, 2. So therefore, this is the graph of the relation R. So we can also rewrite this in set notation. We can write R to be equal to the set containing the points 2, 1, 3, 1, and 4, 2. So these are three different ways of writing relations between two sets A and B. We also call the set A the domain of R. So A, or the domain of R, is going to be the set of all values such as 2, 3, and 4. This is the horizontal components of each of the coordinate pairs. B is also known as the range of the relation. So B is equal to the range of R, which consists of the points 1 and 2. And that's pretty much the basics of relations. So in this video we're going to extend upon this idea. So first, consider a relation R between two sets A and B such that for all x inside of A there exists a unique y in B such that R takes that value in A and maps it to that value in B. But the key word here is unique, and I'm going to illustrate this with a couple examples. So if this is the case, then R is called a function, and some people say a function of x. Alright, so let's illustrate this with a couple examples. So example 1. So let's assume we have the sets 1, 2, 3, and the range of a relation is the set 3 and 5. So let's define f to be the relation between these two sets. So 1 is going to go to 3, 2 is going to go to 3, and 3 is going to go to 5. And let's also consider the graphical representation of this relation as well. So let this be x and let this be y. So we have 1, 2, 3, 1, 2, 3, 4, 5. Let's graph these points. So 1 goes to 3, 2 goes to 3, and 3 goes to 5. So what does this definition of a function say? So consider relation R related to A and B such that for all x in A there exists a unique y such that x goes to y. So is there a unique y that 1 goes to? Well, 1 goes to 3, therefore 3 is the unique y that corresponds to y. So with respect to 2, is there a unique y that corresponds to 2? Yes, that number is 3. Now in terms of 3, is there a unique y that corresponds to it? Yes, his name is 5. Therefore, for every x, there's a unique y that corresponds to it. So therefore, f is a function. So f in general is a relation, but f in particular is a function. F-U-N, there we go. So if this is a function, sometimes we extend the notation a little bit more. We also write that f of 1 is equal to 3. So that means 1 goes to 3 underneath the rule of f. f of 2 is equal to 3. That means 2 goes to 3 underneath the relation f. And also f of 3 is equal to 5. That means 3 goes to 5 underneath the rule of f. Alright, so let's consider another example. So example 2. So consider set A and B. So we have 1, 2, 3, and 1, 2, 3. And consider the relationship such that 1 goes to 1, 2 goes to 2, 2 goes to 3, and 3 goes to 3. And let us call this relation G. So this is going to be set A and set B. Alright, so let's also consider the graphical relationship of this relation. So what do we have here? We have 1, 2, 3, so 1, 2, 3, and 1, 2, 3. So 1 is going to go to 1, 2 is going to go to 2, 2 is also going to go to 3, and 3 is going to go to 3. So this is the graph of relation G. So is this a function? So that means for every x there exists a unique y that corresponds to it. So for 1, is there a unique y that corresponds to 1? Yes, his name is 1. So for 3, is there a unique y that corresponds to 3? Yes, his name is 3. But when we look at 2, is there a unique y that corresponds to 2? The answer is no, because we have two different values that correspond to 2. We have both 2 and 3 that correspond to the same exact x value 2. So if that is the case, then that means G is not a function of x. So it's not a function of x. Now, is it possible that we can quickly generalize this concept in terms of the graphical representation? So notice that 2 corresponds to 2 and 2 corresponds to 3. So if we look at x is equal to 2 on the graphical relationship, notice that there are 2 points that lie on a vertical line that passes through 2. Whereas if we go to the other example, if we look at all of the values and draw a vertical line through all of the x values, notice that any vertical line we draw passes at most one time. So if that is the case, then we say f is a function. So this is what we call passes the vertical line test. And here we have that this fails the vertical line test. So what is that exactly does the vertical line test say? So vertical line test. And some people will abbreviate it just by VLT. So if you consider the graph of a relation R between two sets A and B, where x belongs to A and y belongs to B, then for any vertical line drawn if all vertical lines cross the graph of R more or at most one time. So why do I say at most one time? So it crosses once or none at all. Both of those are okay. Then R passes the vertical line test, and R is a function of x. And that's the wordy representation of the vertical line test. So we can demonstrate the vertical line test with a series of examples. So for example 1, example 2, and example 3. So let's consider 3 different graphs here. So let's consider the graph of an ellipse, let's consider the graph of this type of curve, and let's consider the graph of this type of curve. So let's assume also that each of these is x, y, and x, y. And let's call these relations, let's call this f, G, and H. So if we draw a vertical line on this first curve, notice this vertical line does not cross at all. So that's okay. Also, if we draw a vertical line there, that's okay too. But notice if we start drawing vertical lines here, then we start to run into a couple problems, right? So for example, this line right here, we cross 2 times. So that's not good. So therefore, f is not a function of x. So let's consider the next graph. So if we draw a vertical line here, 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 notice that for every vertical line we draw, these vertical lines cross at most and only 1 time. So if that is true, then that means things are good. Therefore, g is a function of x. And if we look at this last example, if we draw a vertical line there, it doesn't pass. Vertical line there, it doesn't pass. But if we draw a vertical line right here, that passes at least 1, 2, 3, 4, 5, 6, which is more than 1 time. So that graph is not good. So therefore, h is not a function of x. And that's pretty much an overview of a special type of relation known as a function.